That you look like you are tired of studying, exhausted. For today or for good? When you get your transcript. Hey, now the bad news is that now you are studying for your transcript. Now when you go to work for somebody, they will not pay you and start giving you excuses. They say we are still building the dining hall. And you are working. You will construct yours. You construct your school. So what will you do to parents who come to give excuses that they can pay later? No excuse. Parents who come and say, give me a cheat. I am expecting, I'm supplying maize, I'm expecting someone to show. Okay?
You give those students.
So you have few, but who pay?
Yes.
Okay.
It's great for me.
And how will you balance the both? So my food is increasing slowly, but I have this one is the first. And this is the first person I always, and when I'm awarding marks. Look at the list, so those who always just the first, indication that they were here first. So the last time I was here before I left, I told you that you could look at the videos and finish the inductive, capacitive and inductive. And then I rushed to communication system. And after rushing to communication system, we have some good work that we were supposed to do, but also depending on our course outline, which I don't know what I can get. There are many things which we are covered. So far, so good. So, where did I stop exactly? Huh? Resisting. And then I say the inductive. You should teach yourselves. And I put a video. Did I?
Yes.
And I remember going after I had talked about the communication system. So if you allow me, you let me move on with the communication system. And then next week we shall just go through the capacitive and inductive, just how all the relation came about, and then we will finish. But before that, we need to agree on the pattern there. Okay?
Is it only those 5 lectures on where that you are meant to cover?
No. Those are the ones which I had scanned and which I needed you to be having notes on. There are more other lectures. They are, according to the notes here, the last lecture is lecture... No, it is lecture... yeah, it is about that. It's lecture 13, which is about examples of regulators. But look, after communication system, we will talk about the FM and the AM modulation, but like I told you, who knows an AM radio of you? Who has seen an AM radio? Altitude modulation radio? Do you have an AM radio? And it gets a signal. There's no more signal now. Who hustles to transmit on shortwave these days? No. No shortwave, no AM. It is now FM because it is more affordable, more realistic. So I tried to rest on Wednesday, but you guys already, because of electromagnetism, I still injured myself. Well, teaching those 2 hours is not easy, and because I love the thing, so it flows. When it flows, but my head does not change. But I'm better. My nose may be congested, but I feel better physically. It's not like how I was on Tuesday. Tuesday was bad news for me. I went home thinking I'm really sick, but it was just stress. So there is something I wanna look at when we start, as you guys are talking. So like I was saying, the other part is about the instruments. The multimeter, the oscilloscope. Do you need much about the oscilloscope?
No. Yes.
Yes, no. So I don't know, when I say I will scan, I don't know whether I am telling the truth or not, but I should scan the rest of the lectures. The other 13 minus 5 is what?
8. The other 8.
The other 8? I just want to look for something here, then I start.
Saturday, in the remaining 1 week.
I don't want you to worry. We've covered enough for you to understand this course.
Actually, we should change its name for robotic physics.
It's a blessing that your exam is the first one, meaning that I will be able to mark very fast. You know your results. Maybe I shouldn't say that, because if I say that, then it's like how I said I'm going to mark your stuff very fast for a test, and up to now I have not marked.
No. In this year, he has like Christmas, what happened? You'll be receiving marks in Christmas and 25th.
Yes, there's no. Is this for Christmas also? Are we heading towards Christmas? No, this is in November.
No, like,
The
we shall finish exams and we finish marking.
So on the 25th of December, I give you your marks. After Christmas.
Should be after Christmas. That's what I'm scared of.
So you want me to give them when? On the first? Or earlier?
In 2025.
25 at least.
Oh, that is illegal. I have to finish a year's work.
Good enough you are the bus.
No, I'm the boss here. When I reach there, there are other bosses.
You're not the bus.
I'm on the boss here. I'm just checking something so that I'm sure of, so So before, just to, in case I don't say anything later, this is supposed to be 3CU, okay? Which is an electric. And if it is an electric, there are 5 numbers. Attempt 4 numbers. Okay? And it is valid for 2.5 hours. So I wanted to highlight that. So I wanted to check this information. And, I wanted to check this information so that I am sure about. No, not yourself. I don't care about you. No. I know you are strong people. You are intelligent. You are capable of passing in any methodology that is available. So I just don't care, but I respect you. I know you will manage. So allow me to, if you want, I can go backwards and then start on the inductive sensory element. But I don't see anything special about it, other than having, for example, an aperture. An aperture is like a iron core, and then when you wind on it, a wire or a coil, then to produce a field. And if you put another iron core here, then you will be able to feel that field. And then this separation here, this gap here, varying it can now vary how much is felt around this place. So I don't want to go in that direction. I wanted to go to finish up the communication system, then touch a bit of the FM transmission and modulation, a little bit of it. And then next week we can, I would have marked, I am sure, this flu will be gone. Tomorrow I'm going to sleep the whole day. I'll be fine. Even today I did proof, but then I was in a PhD in defense as a cameraman, so I kept my nose covered in a mask, so probably I should have gotten fresh air and healed easily, but now I suffocated myself again. The same jobs remaining just near me. That's why I sound with the clogged nose. So 2.0, did we write or I just quickly talked about it? But I drew the diagram. You are not trustworthy people. So this is an electrical communication. And now it is on me. I didn't have lunch. From there, just picked things from office, came here. So if I collapse, I'm in charge. So an electric communication system, I still feel like this thing of going through with you, writing on board for this course, is child labor. It's child labor, yeah, the notes are on Mwere. So since notes are on Mwere, allow me to, I would have loved to have the notes, but I can't. We have only today, and next week, we haven't agreed the party. Because I know today you have no excuse of rushing anywhere. So when are we having the party? Okay, Thursday is perfect. But that Thursday, if we have to first study, and then maybe as the other ones are arranging the place. Then remember I had promised that they may eat anything that we are expecting if we have to finish at 16:30. And Friday, I already have an open forum on Zoom. And I don't want to do it here. I want to do it home. So that when I'm done with it, I just sleep. So, what do you have on Thursday in the morning?
We have statistics, but MGM things, we can begin our lecture immediately after lunch.
We meet 2 to 3, 3 to 4. At 4, the catering people should have already brought the food. Those ones who refuse to do this course will be the ones to arrange the place.
On food I can arrange.
No. So when we finish here, straight away we go down. So that means I will save my maize. Since I have promised that I'll harvest it. If it is ready, I'll harvest the maize and bring for you to have, it's called what? Barbecue sauce. You roast maize.
Maize roasting.
As we also eat. I'm sure there are people who don't eat maize.
Not in this course. Those are the characteristics.
I'm sure there are those who don't. Okay, so because I want to make the order at the canteen, they know that every year I organize a party, so the only change is about the snacks they have to organize. And my salary has a budget that every year some portion of the money has to go back to the suppliers, the clients. It's a giving back. So Friday, tomorrow, 4. Doesn't matter, until, but the cameras will be there.
Dress code.
Dress code.
Putting your Germany.
White shoes.
Dress code. Dress code is that it is an extension of the course. Mainly it is meant for electromagnetism. But since you are a subset of electromagnetism, the part is normally, I was always doing it for electromagnetism. Electronics is an elective, so I was able. So since you are all of you who do apart from maybe 1 or 2 or 3. Where you been? So we shall start at 4 and be able to finish. I normally, as once I have food, this is the procedure. Bianzi is the DJ, he accepted, so he will come with the playlist. Fred will look for games. Most students have come with games which I need to know. But this is what I normally ask for. All of you, one by one, you introduce yourself, you tell us what you don't like about me, tell us what we don't know about you, and any other thing that you want us to say. I have always hassled with students who want to give a speech almost for 5-15 minutes. Those who want to talk, I've always been surprised. So those are I can give you the hint. Those are the things I want from you. The remaining part, some people always choose to dance for us. They dance, then when the DJ puts, people continue dancing. Mostly I would even go to my office, you do whatever you are doing. Once you are done dancing, you say we are tired. So that's the procedure. I warn you, you will see behavior that you have not known about people. Those who you see like my saying, I'll be a soldier. Very tough. I'm not stopping you from asking for, but I have seen people who are quiet when they eat there, they do amazing things which I didn't know about. The rest of the things that you want to do as students, I don't know in terms of how. Then after all that, we pray for the exam, and then we go home. So, party. So our party, first of all, let me not rush the party. Exam. Exam. The first things first. The exam is on the Monday, November 18th. And it is from 12 to 2:30. Is that the time? I want to check on the timetable. The date is 18th November, then 12 to 2:30. So it's the big morning exam. 12 to 2:30. Okay. Party. Party is on November. Just put it on record. November
next week.
14, 2024. 16 hours. Till late. That's it. Okay. So we were supplied with those electrical communication systems which have amplifiers or whatever, but we have never used them. Those black things, those decks. They are a stack of them. They fit in each other, and there is a power supply, and they keep going in each of the modules. I had promised to work on them and make sure they work. But you know what we have been going through. Even our own practicals, it is a hassle. By the way, how do you find practicals? I find it very strange, but I am the instructor. The only practical I find valuable is the robot and the segment. Others, we are reminding ourselves of electronics, but most of you, I see you fidgeting. Yes.
I have a concern. It may not necessarily and of course I'm not going to be doing it. But if you were here as a student, you were here as a student some years back, and I think most of the lecturers that are here. So they were here as students, and then they saw the challenges they were facing as they were doing the experiment. You realize you're doing an experiment, you don't have any knowledge about it, but you're going to do an experiment. I don't know that you call that such a challenge, and then what you're experimenting now, maybe you're going to study it after 2 months. Now, does the practical and the experiment still make sense to the student?
Oh, I have campaigned about, I've done this politics from very Christian magnerism. Our time, we had courses. I don't remember the code, but there was a first year course strictly for practicals. That's why these manuals, that's why I bought these manuals you are using. If it wasn't that I brought these manuals you are using, you wouldn't be doing any practical electronics or electronics and instrumentation. If you look at the new manual, just like we have not done any practical electromagnetism because most of the experiments are done now. So we had a first year course in, I don't remember whether it was both semesters, but we had a course strictly for practicals. Second year, we had a course strictly for practicals. Third year, we had a course, we had electronics being done in third year. First semester, we will do electronics. Second semester, we will do, no. First semester, I don't remember whether we had practicals. And then in the second semester, we will do practicals now of the electronics. We used to do electronics in the second year. And then third year, in practicals, we used that knowledge. At least that was very bad. Then we revised the curriculum. I want this one for you to get as much as you are already exiting. So the curriculum was written to integrate relevant experiments in each of the courses. You get my point? So electronics will have experiments only for electronics. Now let me use electricity and magnetism, which we went through together, and I campaigned. I remember doing the CRO demonstration. The theory was that we should have enough apparatus. So if I teach about the 7th segment, we do that experiment, all of us. You do it, you see the segments, you make a report, you all know what the 7th segment is about. If I teach about the sensors, we all know robots, all of us. You see the robot, some of you do the touch, another one they do ultrasonic, others do the light sensor, color sensor. We just say sensors finish. But you are a poor government. So we can't have apparatus for every topic. So we draft practicals for practicals. So I'm teaching electricity and magnetism. I'm still on electric fields, but some of you are doing is it called the power factor? This one, something with A omega. You are doing things with A omega. When I'm doing electric fields, you are now doing an experiment of an oscilloscope, and you are supposed to find out those expressions. And I used to almost cry. At least here it is fair. And that's why I delayed practicals this semester. We start when you have an idea. None of you can say that they don't know what that experiment of segment is about. None of you can say that you don't know nothing about the robot sensors. These are the ones we covered them in the electronics. So we know. But there are things that we can't explain to you people, because some of them are even, but it is all about your poverty. When a project comes, people jump on. They say, let's change the curriculum. But you don't have apparatus.
The other concept is, me as a student, the moment you give me feedback from what I presented, at least I can try to find, okay, I can notify my errors. But I've been here from year 1 up to that year. I've never seen my results for practicals.
Are you sure? I put results for,
No,
I don't remember for electricity and magnetism, but for electronics I put them.
not necessarily.
You want to see how I mark?
Yes.
You come to my office.
No, okay, not sure, but I'm telling you.
I don't know about others. If you want to comment on that, let's feed on here. If you make a complaint of me, if you make a comment about somebody else, I wouldn't know.
We have a party
On mine. And the practicals, the reason we don't give out the scripts is because you would give friends.
Put on flash and share.
People used to do this. And it was funny. You get a script of those who got 8, for you get 5. When you have Xerox, you Xerox on the script which is 8 marks. So it was resolved that practical, I know because you did computation and the lecturer was busy saying that use your results. Now that's when it came to your mind because he's not, he doesn't know the culture here. So our culture is that you don't give out the scripts because students will just Xerox. It's an experiment. It should give the same results. If I copied that you give less marks, I can even complain. And if it is allowed that people should have their scripts, I would say, but these ones on the same experiment got 8 and I have the same results. I don't know whether you get the point.
But again, we are not highlighted more in the practical results.
Well, that is what I was saying.
Well, I don't know. I would wish to give out everything. I marked your stuff, finished it there in the file, everything is there. I think one of you, the students, came to me after that exercise in computation, and I said, we don't. But here are the things. If you want to check your scripts, how I marked, they are here. I have them in a big file for electronics. I marked everything and graded and put. I'm going to mark your electronics and instrumentation and then put in a file. If you really feel you didn't get what you want, you can come and I show you the guide and the marks. I don't know about others, but I will be able to show you mine. But the reason is that if you gave out scripts, students wouldn't do. You would actually Xerox, come here, pretend to be connecting, you are not even asking. Then when time reaches, you hide whatever rough you were doing, then you bring very nicely written stuff. Sure. And for me, when I reach, I'm like, yeah, this one is the red. 9 out of 10.
10 out of 10.
And then I see you pocketing, I say, that one we smashed. And that's why I do not give you offline assignments. I don't give you questions. Because one fellow will do. You can imagine, we used to have those cases. You sit down and crack your head, write the assignment because you are annoyed of overdoing, you write anyhow, then someone Xeroxes from you. She writes nicely with underlines with double lines.
And corrects the mistakes.
Gets a difference of like 5 marks from yours. It is painful. Yes, anyway.
Adding to Mugambe's point, what he has said, I think it makes sense also. Because
who said it?
because I also complained it one time to Dr. Liz, because if we look at the electronics last semester and now this semester, electronics and instrumentations, they are almost the same practicals we did, and we are redoing them, but we cannot even reproduce or redo what we did last time. So, meaning that at the end of the day, we are not gaining. Or what we are gaining is so little. Because if we did it last time, now this time we would redo the practicals by ourselves, but we can't. So I think these practicals, you need to revise how they are conducted, you as a team, because there is a big problem.
No, I like your boldness, but I don't know whether you are keen. Yesterday you were not here, but I don't know whether you are keen to look at my facial expression when I'm here doing practicals, and I don't know whether you were here when I chopped off my wires.
So last time I was here.
Yes. I am frustrated also. There is no way you are going to gain anything from that fake oscilloscope. The probe is by 2 wires. You don't even know where to put them. If you were to do like the way you are saying, under normal circumstances, you should even come here unguided. Just go to the manual, follow instructions. But today the probe looks like this. tomorrow the probe looks like this. How will you do
But
it?
if what you have said is correct, because I can't be known the result, then I come here and tamper with the instruments. Just say it in the paper.
So the frustration I understand, and I have no control. If I was in charge of this lab, at least also scope, I would know this, like how these robots are being handled. At one point now I said, let each camera have the components of the given robot one is going to do. So what we don't rummage through the thing. So I would know this experiment takes 5 wires, takes this many, and make sure that is what is there. So I get frustrated. I had to chop off my wires that day. So if we had, you are using that functional generator today, you reach there, you are using the one with the red whatever, the other day the pharmaceutics were using the other one, which even you can't know how to adjust. Then here you are using this analog one because you can get you can make it just give you peak to peak, then the new oscilloscopes. The digital ones, they can't reach the lower frequencies. It should be uniform. That's your it's where you live, you know. The ones who did the robot yesterday, I showed them the videos, and I've showed all of you who have done robot the videos of the autonomous tractors. And then I've asked you, these kids are making mowing machines. Yours are making cakes. And then when you expect your child, when he goes for a scholarship in the US, you expect him to do aeronautics engineering or robotics engineering when they are making cakes and the other ones are coding. One time a lecturer for math methods, I think I told us that you people can be environmentally friendly. Tell students to collect all bottles in the compound. Then tell them to measure the diameter. Get a string, go around, measure the string, and then finally they dump them at the right place. When she finished, she said, if you have any comments, you come by and tell me your comments. I went to her office. I said, what if I'm in a school like Vienna or Cambodia? These are kids of the Bean Stars. Even at home, they don't wash their hands. How am I going to tell them to start collecting garbage if it is there anyway? Because they have a compound attendant. And you are telling me to tell, what if they get an infection and die? And they say it is TWINAMASIKO was teaching them math by collecting garbage. So there are things which we want to remain local. I don't know why. When they see you with nice things, a nice computer or tablet, they say, that one is showing off. We just want to be local. Anyhow, so any other heated comment? So an electrical system, I'm sorry, I'm just going to run through and then it will be up to you to sit down and since you have discussion groups, you discuss. Where you don't get the point, the videos are on YouTube. You go, you look for the exact video, you can scroll to where I was explaining that point. Otherwise, I may only cover just a bit. So we have a source, so a communication system, we can talk of it as like a radio station, then transmission, and then a radio receiver, the radio which you listen to, or a TV, anything that is used for communication. So a source is source of information. So if people are in an office, in a studio, that is the source of. It could be good information, it could be fake news, it could be poisonous, like they say, like the coffee bean. So if they are in a talk show, the information is the coffee bean. So they will talk. That is the information. I mean, that is the source. So the source is where you generate this information. And once you are generating this information, you have to talk through something. And that's where we say we must have a transducer. And transducer, remember, transducer can be input or. So at this level, if we are following the levels of the communication system, this would be an input. So you are now speaking via the microphone. How many of you have been in a radio studio? Why are you putting the hand very fast? I'm not sure. How many of you have been in a TV studio? Like talking or just looking at the thing?
Okay.
So when you are in a radio station, depending on which one, there's just a small speaker here, with, placed on the table. Or if it is an advanced studio, you have these ones which there is no other addition apart from the levers helping you moving it from friend to friend. In a TV studio, they will always hook their wires, put a microphone here, and then the transmitter somewhere, or they can just put it on the table. But if they expect, if you are there on entertainment, they may have to hook the transmitter set on your belt or whatever, or in your pocket, if you're going to move around. So the microphone will be your input transducer. So then from this microphone, you have to transmit it. So we go to the transmitter. And once you go to the transmitter, now it is now the transmitter. Of course, transmission now includes a lot of things. And this is where we do the idea of modulation. So it could be you can modulate frequency. So you talk of the FM, or you can modulate the amplitude of your signal. This is our signal. So if you are modulating this here, this would be, you are here modulating the frequency, because this is low frequency compared to this one. So this is FM. Now if you are trying to modulate this from here to here, then this would be AM, amplitude. So after you modulate, so if you are modulating frequency, you use less power compared to when you are trying to modulate the amplitude, keeping it at a very consistent value to make sure that it reaches where you are taking it. Now, then it's up to you. If it is like a phone, those days of the phone which has a wire, you need that wire. And that is where we talk of the channel. So the channel could be via the wire, or wired, or wireless. If it is wireless, it is where we talk of the free space. Like how we have the Wi-Fi. Each one of you now with your phone here, you are able to get the Wi-Fi from the corner there. You don't need anything. But if you wanted to use the internet cable, this one here, you have to plug it in your PC in order to be able to. So this would be your channel. But for now, we are using so this is a physical medium which is used so that the signal from the transmitter can be taken to the receiver. And then now, the next one would be the receiver. So if the receiver is a radio, the radio is a receiver. But then what the radio receives, you get it through its speaker, which is a transducer. And this transducer here is the output. So with the output transducer, which is now with your speaker, you can now eventually end up with the information. So information was collected here at the source, and then it is received at the destination. So we would be here listening to a few things. Now after this, we do the modulation. Modulation, this is the transmission of an analog signal by impressing on it either amplitude, phase, or frequency. And this is of a sinusoidal, this is referred to as carrier modulation. Why do we modulate? We modulate to match the bandpass characteristics to the channel so that we are able to transmit our signal. How do we choose the modulation? We choose the modulation depending on the characteristics of the message signal, its bandwidth. That is about the signal. The characteristics of the channel, e.g. the type of transmission medium and the type of the channel. Then we have performance requirements. What are we going to use the whole stuff for? Then are they expensive or cheap? The economics. All of you would want to have a big subwoofer system in your room where the bass is shaking the walls. But because you are broke, you buy just a one subwoofer where you put the SD card and then you celebrate that you have. But there are people in our times when they would get fucking allowance, they would get like those things. Sony, they pile them like one on top of the other, like 10 of them. And then they would have speakers, Sony speakers, their rooms would be shaking. For us who are broke, we just keep enjoying people's music from the other side. So we have amplitude modulation, whose general assumptions are that we can talk of a low pass filter where you just remove the low frequencies. It has a zero mean and it is limited by band. So I don't want to go deep into that. So the ways of amplitude modulation, you can have a double-sided band suppressed carrier, whereby if you have an input empty, then you can have the output, but then you put the carrier. Then you have to remember do you remember are you conversant with the Fourier transforms? Which I call the Fourier transform and you laughed at me. Okay, so you have to use the Fourier transforms in order to understand a little bit of amplitude modulation. I don't know, I'm trying to just rush through. So after this, you do synchronous. So I want to just rush to the part. I'm sorry, we could have done better, but what I wanted to say. And before you finish your point, I put all the textbooks. Is it true?
Yes.
Yeah, the one for communication systems has all these things, and the one for electronics is it electronics and instrumentation or instrumentation and applications? I don't remember are you on web? The references. If you go to the course materials 2024, even there is no need to even discard these remaining lectures. All those, even the inductive sensors, all those expressions, even for the capacity, those expressions we were struggling with are all there. It's big.
Yeah, it's better. You separate them
You people, you came what? You came to have a good life or what? My friend, do you know why I'm in front of you? It's not that I'm a genius. I was lucky to graduate before you, but also graduate with a difference. And it did not come out easily. I showed you that I'm using my notes of campus. These are my notes. These are my notes. These notes are older than all of you. these are my notes of that time, and you can see how I was always making notes with nice. This is how I would write the volume.
Senior artist.
Which year I can check for you the date. I used to write, I was organized, I used to write for the date. I would go to my guardian and go with a cheat, tell him I need money for the papers. Thank you very much, then he will give me. So this is, the date is 00/12/13, meaning that it is 13th of December 2000.
I'm older than you.
You're older than them. You're older than them. By how much?
By 3 years.
Maybe it's 1990.
This is 2000.
I'm older than you.
This is my
1 month.
This was December.
December.
1
1 year.
Lefty,
Yes?
when you talk about
1 year.
a modem, how is it modulating? You see like the FM or the involve another special modulation?
The modem is not about modulation, it's about conversion. So, you said the modem,
Yes.
like one for internet.
Yeah.
I don't know, I will check.
Converts.
I thought you had talked over the recorder. The modem I don't know, but the modem is like the way we would use the router. But for it, it's acting like, I think it works on the most of them use GSM. Anyone here who knows what GSM is? Well, like they act like a phone. So you dial like you would be calling, and then you connect to the internet. So most of the modems will need a SIM card.
Service provider.
And then, even beyond the service provider, you need a SIM card, and then they will work as if you are using a phone. And then they connect you. But the electronics in it, of how the transmission works, I don't want to wise, but I can Google up, because I have little electronics, I can be able to explain it once I have, but I've never bothered to. And nowadays they are obsolete, because now we are using the 4G, 5G with our smartphones. In the first modem I got it in 2007. It was very big. Now then they brought a USB port, like it's like a USB stick. And now I don't know anyone who still uses a modem.
Oh, yeah, if you are watching football match, they score a goal here and they may name or they have not yet celebrated a goal. So
It's a time delay. Now, especially when we are using the satellite communication, right? So, this is in UK. So you have a tower in UK Premiership. Right? Then the transmitter sends to the satellite. So when it sends the satellite, this satellite now codes. So it is quick, but it has to make sure that whoever paid is the one who gets the what? The signal. So there is that delay in the processing. Just like when I call you, those days it would have first go to some switchboard somewhere and then come back to Uganda. Like they were telling me that any Western African country, in order to make a call, it has to first go to France. Or the switchboard in France, and then the people receive the call. Otherwise, they are big monitor. So you can't say anything without being heard. So this delay of first going to the satellite and then from the satellite to the even now, I told you I watch many TVs at home. I find without them being on the same antenna, when I have this one here, and this one here, and this one here, and they are all on NBS, there is a slight delay. When this one is raising the hand, this one, the hand is around here. This one probably waits a moment. So the issue is about the delay, time delay. But sometimes it is caused by what we call, I say it also, malpath. So you find that you are in your house, but the signal that you are getting that is clear is bouncing off the other roof. So the satellite signal comes, hits on the roof, and then your TV here gets the other. Then someone who is on the other side of the building is getting a direct signal. But the delay is because of, it's not about distance, it should move about this time, but sometimes they just delay it so that you, I don't know how to call it. In the live broadcast for like presidential, like when the president is going to talk tonight, is it tonight?
Yes.
They do it intentionally to make sure that you cannot, if you had the more ulterior motives, you cannot follow instantly. That now, for example, if I was giving a speech, you can't follow that now I'm standing like this, posing as I explain. So they put a delay. You get the signal, but when it is delayed, so you cannot be sure. You find that he has already moved this side, but you are now getting the signal when it's still on the podium. So you cannot do any automated attack, for example. So, but sometimes it is because of the, you might find that as this signal is going up, it is cloudy. You have seen your signal getting boxes, like small boxes. You have seen an image getting stuck, like for a few seconds, and then eventually it becomes okay. It could be because you have, for example, a cloud here, or it could be raining at this point when it is coming from the server. Yes, so I wanted to see whether I can. I don't think there is much that I can talk about oscilloscope. You know what an oscilloscope is. You know how to measure the DC from an oscilloscope. You know how to measure the AC from an oscilloscope. Isn't it true? And then the other bit, so that's about the instruments. Can you now explain how a remote control works, for example? Why are you bothering? Kabule has no idea. Kabule has no idea. Kabule has no idea. So I just want to pick from lecture 6. I stopped at 5. So there is lecture 6. Lecture 6 is about analog amplitude modulation and demodulation. So a reminder of the Fourier transform. And then I just want to rush to because this one I will be able to, it is easier to scan it quickly. So let me rush to I've never done this, but I think there are people who normally finish early. And I think this is how they do it. It sounds nice. Yeah, it sounds nice. If I had this stuff on a projector and I'm just scrolling through, we will be through in 1 month. But I believe the learning is a process. Otherwise, the books are in the library, the notes are on Google, the videos are on YouTube. Even for other courses in other universities. So you will be able to teach yourself. But you pay fees. That's my rationale. But sometimes I'm talking, you are still teaching. How?
It's facilities and its needs.
No, you can't do that. You would have denied students, and I'm telling you because you are teachers, most of you. You would have denied students a chance to experience learning. Because today it is cloudy. The feeling you have now when I talked about these clouds, you know they are outside there. So we shouldn't do that. Teach. And that's why they say semester should be 4 months. 17 weeks, 2 for exam. They took away another, so 14 for the learning. Learn up to the end. How can I give students at the university that this week is for reading? How? When you always have nights which are free. So realization of M and FM modulation. And then I'm rushing to see where this takes me to most, like I said, most of these basics are important, but we have moved on. Then frequency modulation, that is FM. The hour FM is done. It uses bits, so FM is a bit so short. And then we go to the next lecture. I'm rushing towards then the phase. So we have you can modulate phase. You know phase. If I have this waveform and I have another waveform going like this, then the difference, this should have been the same height. So the difference between these two here is what we call the phase. And the phase is the same as the angle, that phi is the same as this difference here, delta x over, is it 360? It is on our guidelines for practice. So you measure, you can use an oscilloscope to measure this distance here, and then you divide by 360. Is it divided by 360 or divided by the frequency times 360? I think it is delta t over t. Why am I suffering when I could be having you take it the way you want, but I don't have time to stick my head with everything I've taught. I don't know whether you understand me. Like pile up everything I've taught, I would be running around as a madman. And I wouldn't advise you to do that either. That you go around knowing that C is equal to this. If you can get it online or in the notes, please get it in the notes and let your head be clear. But if you are going to exam, then you have to fit everything in your head. Exam is different. I don't have the practical guidelines here.
It's changing T or T
Times there is equal to 5 over 360. Yeah. So this should be 360 here, and then when you make phi the subject, it becomes the change in T over T times 3. And then you get the phase. So you can modulate the phase, either make them be in phase or see if they move out of phase. You can modulate the frequency. I've already said it there, or the amplitude. So these are the types of modulations that you can do. Amplitude modulation, frequency modulation, phase modulation. And these are in the books which I gave. So you just come here to get a few bits. The textbooks, those are the key textbooks. And if you look at what is stated in the outline, you'll be able to get what you are supposed to get. Kauma, you are very quiet. Then we have digital modulation. And then we have sampler, we have quantization. And then, so I'm rushing to see whether I can get the instrumentation part. I enjoyed it briefly in COVID. In 3 weeks, I finished the electromagnetism and people passed. In 3 weeks.
People didn't experience that.
We would meet, I think, on the Wednesday, do a test, then on the I think Tuesday we'll do a test, Wednesday, then we revise the test. Then next week we do the same, we did the 3 tests, and then they said, we are now ready for exam. And they passed. And it was true. The distance ones never even attended anything. And they told me, we are ready. And they passed also. So why not you? Radio broadcasting. The radio broadcasting, we have, so the an FM radio constitutes of it's a typical communication system. So the reflex receiver, like a radio receiver, I wanted to, you have an antenna, then you have an autodiode converter, then you have an amp, then you have a detector, then it goes back to the audio for feedback, and then you take it to the amplifier, and then you get a speaker. Then you have an antenna for broadcasting. You first make it go through a mixer by putting in a local oscillator signal, bandpass filter, then an amp, demodulate, then amplify again, then it goes to the speaker. I'm enjoying this. I would love. So, lecture 12. I might have been talking when no, I don't take it too hard that lecture 12. These are just lectures for distance education students. They are just made, you saw them, those 5 lectures. They are meant for distance education. So they are like the reason they are many is because each of them has objectives, introduction, and then at the end of the thing are examples, then self-assessment questions, just like that banner book of the 2 standard organism. So it's not that there are 12 lectures because that's how heavy it is. It's because of those, like you subtract like 5 pages for each lecture. If they are 13, you multiply by 5, those pages are really not what you will be reading. Because these are objectives of the course. Then example and exercise. I don't know whether it makes sense. Because at the end of the day, these are 213 pages. So what is 13 times 5? 65. So you get 213, you take away 65. I'm just calculating that part of you find that you have 5. So, and the examples of measuring instruments, according to the course outline, is that we discuss examples of measuring instruments like a multimeter, the oscilloscope, pressure gauges, and the general principle of the multimeter and oscilloscope will be presented in the capacitive pressure sensor in particular. And if you remember, when we looked at the capacitive transducer, is it transducer or? I'm just looking for the exact word. The voltage that eventually gave us that was giving us I don't know whether the pointer for the fuel gauge is like this. So the pointer is here, this is full, this is empty. The value you get here, I think is this inside here like this. This pointer here, that value it shows you is because of the voltage. And this voltage, you can get it from the, once you put this capacitor. So you put the capacitor, so here you can still have your resistors. So this voltage here, so you can use the bridge to come out with the voltage. Which voltage will be able to give you the value of the measuring that you are doing, the variable that you are coming out with. So the multimeter is one of the most common electronic instruments, and it is sometimes called an AVO, and this name is arising from the fact that the meter measures current A, voltage V, and resistance, which is in ohms. So when we say AVO, it means amperes, volts, and ohms. So we can change a milliammeter into an ammeter. And what do we do? When we have a milliammeter, what do we do to change it to an ammeter? So there is what we call a multiplier and a shunt. So which of these ends up as an ammeter? So when you put a multiplier, what do you get? You multiply things, so you make, it means that you are making it live, so it can only be about voltage. And when you shunt, that means you are giving an alternative. And through that place is when you can monitor what you diverted there. And this one gives you the ammeter. I hope this is the truth. So then this one is an A-level stuff. But is this true? That a multiplier gives you a voltmeter and a shunt gives you a voltmeter, an ammeter? If you say so. Then you have an ohmmeter. Then you have how to measure AC. You remember AC? You can use the principle of magnetism, so you make a moving iron meter, or you can use the principle of heating, which doesn't care which direction it is. And then you have the hot wire meter. And then we go to electronic meters, these ones which we have been using here, the multimeters. So electronic voltmeters, ammeters, and ohmmeters use amplifiers, rectifiers, and other circuits to generate current proportional to the quantity being measured. And this current then is used to drive a conventional meter movement, PMMC. And the instrument can be analog with a continuous scale, read out, or digital with the digital indication as mentioned. In first year, that experiment 5.1, you could either use an analog meter and then you measure, you start looking at the whatever, or use a digital meter to get the value straight. So the electronic meter, VOM, volt ohm multimeter, is in general has the basic elements. You have a balanced bridge, that is DC amplifier and inductive meter, range switch. You've been struggling with the range. I think those of you who were doing that experiment yesterday were fidgeting with a meter, saying how do we go from millivolts to volts. I don't see all those guys who were doing 22 guys, not there. Yeah, she's there. She was the secretary. Where are you? Because now at least all ladies are here. Where are your people? You are Margaret. You have one of yours here? No problem. So Shirat knows that they were having issues with the range. They did not know how to move from millivolts to volts. Once you tap on the range, it goes. So then it has a rectifier section, and then an narrow batteries, and then a function switch to select various measurements function. Then the oscilloscope. The oscilloscope we cover here is the cathode ray oscilloscope, CRO, as it is also known, is one of the most versatile electronic instruments used in the laboratory and workshops. When we say workshops, we don't mean these workshops of hang and whatever. We mean a workshop where the mechanic or the electrician works. And it can be used to display waveforms. So most TVs come with an electric circuit, and then they tell you on each point which waveforms you should be getting there. So if you have that circuit map, you can get an oscilloscope and say, here they are saying I will be getting this waveform. If you don't get that, it means there is a problem before that all start. Then but sometimes the TV I bought when I was abroad had a very big circuit, and it was part of the package. It died. It just refused to work from nowhere. And I tried to open it, I think I spoiled it more. The ones I buy here, you buy even almost the manual for the simple things is not there, so you fidget everything. But those people know how to make sure that you can be independent. Unlike you people, we here, people abroad, not because of my recent visit, but people abroad want to do things by themselves. At least for the country like Norway where I was, there are no house boys, no house girls. It's not like those Arabs who are enslaving our children. I don't know why I would go to work in an Arab man's home, washing their clothes. When we have, and after selling land in Masaka, when I can grow coffee. Live a dignified life. You can live a minimum life and be dignified. Then you can go there, you are sleeping in a dormitory, you see them, those of you who do TikTok, you will see how they live in a dormitory. I'm sure all girls who have gone to the Middle East are going to be useless for the country. Yeah, I'm serious, because the way they live, that lifestyle, you come back when you are traumatized. Even if you are so strong like how, after 1 year, 2 years, and you are seeing how the Arab is harassing you, and then there is a fellow Ugandan, you give up. You enjoy life. Then you come here when you are used, okay? Because there is nothing much which you get when you are there. And when you come here, you find your relatives using the money to enjoy life. And they used to send you photos of a neighbor's house. There is no house for you. Or they break your house like they did in the Rubiji. And you tell me that you live I did chair you. I did distribute newspapers. I respect people who, if I was to give anybody my money and you misuse it, I will cut off your head. One day I fell down in the snow and I hit their knees on a bike. And then you hit my money. Because we used to distribute newspapers. They would put newspapers like at game, and then you have to distribute them in a Kororo. People have boxes. I wanted to do that business here. I wanted to go to Kororo, register people, put the boxes for my company, and then New Vision gives me, and then with my team we distribute to. So, and this was not a bad job, but now, washing people's things, they are shouting at you, others are beaten. Anyway, That's your opinion. Some who, of course, any girl who was not having hope and is there and then comes and now can put on the musical, they are happy. But you who have got a chance to go to school and you score a good class and you become a good citizen, I don't think you should be thinking in that direction. I have a bunch of students who went to Italy the other year. They were telling me, I think one of them was telling me now they are now going for their masters in Netherlands. Not to go to the Middle East. You want to finish your name on Middle East? To make TikTok videos as you watch people's bodies? So oscilloscopes can be used to display waveforms. I went astray when I was trying to show you that people want to do things by themselves. You find a man with the toolbox, with the garden tools. If it is garden time, he puts on his gloves, puts on his boots, his overall, he cleans his garden. If it is a vehicle which has a problem, he gets his toolbox, rips off the vehicle, replaces either gasket, replaces the oil, changes the oil, and then he's done. Here, a small thing, even put in water. Say, hello, the vehicle is going to, you come and help me with water. Oh, a tire. You find the lady just like this on the road, my tire is down. So, once they are able to tell you what waveform is on every node within the circuit, then you can find out the fault of your TV, for example. We can use oscilloscopes to measure the amplitude of the waveform. We can use them to measure the frequency or period of the waveform, to measure the phase or phase angle between the two waveforms. And the oscilloscopes, they have two physical effects. We're able to see the stuff we see because of the fluorescence on the screen. When the electrons hit there, they glow. They make the place glow, so we get those waveforms because of fluorescence. And then the force on the charged particle. When we are using the vertical plates, we put a force on the waveforms, on the electrons, so they can move down or up. If we use this one, then that's when we try to make the waveform move to the right or to the left. If this is your left, if when you are making the waveform to move to the left, your left, you are using the horizontal plates. So fluorescence, certain materials called phosphorus give up energy in the form of very visible light when struck by fast enough electrons, and the brightness depends on the density, and the speed of the charge carriers. And phosphor is, when I was young, nowadays I can't. We used to go to the garden, and when we would leave late, there are these plants whose roots would have developed some whitish things, and they would glow in the night. But there are these insects which are funny. They have their I don't know how they call it. This other last part here gives some nice light. I wanted to grab them and rear them so that I can notice how the disco lights in my compound. So I don't know how they do it. There are some people who are superstitious about them. We call them stars. My language, but they are stars. They come, they swing around, they fall, they can land somewhere. In the day, they don't do that.
In the rainy seasons.
In the night, they do that. So I don't know how they do it, and what they might be interested. So this is just to make sure. So the operating modes, you can have display functions, and then so there is a diagram for an oscilloscope, and I showed you the oscilloscope, the ripped one. So was it during the introduction of the lab when I brought that oscilloscope here? Even the other side. So you have the Y amplifiers, Z amplifiers, time-based triggering, and then trigger level, and that basically tells us about the oscilloscope. And then the pressure gauge, we did it in the capacitive pressure sensor. And then that covers the oscilloscope. Now the last bit is about examples of regulators. We did regulators. A Zener diode was an example. No matter how much you would be putting, it will start conducting at a given value, and doesn't matter how you. So, for example, when you are getting harvesting sunlight for photovoltaics or for solar energy, if I can use that simple language. If you are doing that and you are using so the components are that you have a panel, and then from this panel you must regulate this charge that is coming from the panel, because the panel has variable sunlight. If it is cloudy, the voltage will go low. If it is so like clear, then the voltage will be too high. So you have a varying voltage, but you want the charging voltage to be constant. So you have to integrate what they call a charge controller. This is a charge controller. And that's, it involves a regulator. And then from there is when you go to the charger, then you charge your battery, and then you can use that later on. So the regulators, we need to discuss the general principles of the examples of regulators. Namely, you have like a thermostat. I told you about the thermostat of the vehicle, which makes sure that the water from the engine, now this one has to go here. If it is needed for the dashboard, okay, the heating of the actual heating of the vehicle is from the water that is from the engine. So when you are pressing either this other button for, I don't know whether it is like this or like this, or this other one, which is I don't know, this one should be for the front and this one should be for the rear. When you press that button for heating the windshield or the back one, you are actually now making sure that water now flows in that part of the dashboard, and then the blowing. There are some fins on the glass here. The air which is coming out now will be warm, and then it will keep making. That's why if it is having dew, and then you start the warming, you see some parts clearing out. Okay, some people get a piece of cloth and remove, especially if it is raining. The behind one, the last time I talked about the behind glass of the vehicle, most of the vehicles, it has these patterns.
Called defrosters.
You don't have anything to defrost here. So you use in Europe there are defrosters because normally snow covers their vehicles. So when you come and you now turn on the engine to heat up the vehicle, first of all to warm up the engine, and then to warm up the glass so that it opens. So for us who have rain, you cannot defrost rain. So once you switch it on, then these ones heat up, and then they warm up the whole glass, and then if it is dew in the morning, the dew disappears. If it is raining, then the water, whatever you call it, the wetness just disappears. It goes off. And so the other one is automatic switching. Automatic switching, I brought here the fake solar camera, which has worked. When I went away, I am sure I left when everything was okay. But also I used to have a problem. Like if I am in a compound and I'm either washing the vehicle, whatever, it is in the evening, I wouldn't know if somebody is peeping like in the gate or whatever. But now, the moment I told you, even the moment borders are passing, it lights. So I'm sure they think I'm like a government official who is so important that I have to take photos of every, like the ones in the road. But the thing is fake. It doesn't. And I had bought the camera which I can hook up on the smartphone and didn't work. Its QR code wasn't working. I gave it back. I hope they will bring me a better one. Also, automatic switching, you can use a relay switch and integrate it with an LED. An LDR. An LDR is a light dependent resistor, like the one which is used on the streets. So I also bought solar lights, which are like this. It is made like this. I don't know whether I mentioned it last time. The panel is here, and then below here, one side there is a light here with reflectors, and then the other side, so it is like this. The other light is here, the other one is here, then flat here with the panel. They also have sensors. So they go off in the morning, they go on in the evening. Now they don't remain on forever. When there is no one around, they are dim. When you come at a distance, I think it is about 50 meters. At a distance of about 50 meters, they become bright. So my place is like an automated, and it is funny. It's when I started teaching this course. The courses I have taught, all of them, when I start teaching the course, things happen. It's the first time when I started teaching the electricity and magnetism, light didn't happen, I explained. Then I started teaching the mechanics, eclipse happened, I explained. Now this one, when I'm teaching it, I was able to, I don't know, she just came with a thing, she had taken long without coming to supply things. And, they helped me to be secure. So, lastly, about these regulators is the remote control. I don't have my remote control here. But every one of you has touched the remote control, isn't it? Every one of you has touched the remote control. Huh? The TV remote control. I'm not talking about the car. So I don't want you to say he's now again telling us about his car. No, I mean the remote control of your TV, but also the other lights. That light which was a fake camera also had a remote. So you can go and switch them off if you want them to work. What I like on them is that they have this beeping light, the red light. And then the sensor was made in the form of a camera. So there is no way, and then they also put a fake antenna, which I plug in, so they have a fake antenna here. So they think because now I have 3 of them installed, so they think like I have a control station inside whereby I have to look after. I hope someone will never come on the gate and start saying, please, I'm here, don't you see? Now, the bimetallic coil combined with this.
What is the use of other LED that is put in the room?
Just to indicate that there is something, that it is working. Why are you doing like this? Your phone charger, some of them have 2 lights. One for if it is off red, those which are local, like for cathode. You find it has a red one for showing that it is uncharged, and then the other one which shows that it is. My camera, because now it is in power, it will be showing green. If I was charging without filming, it will be showing orange. But it is the same light.
But the guy doesn't light.
Huh?
The guy doesn't light.
The guy doesn't light. Which guy?
On the remote.
Huh?
On the remote. On the remote.
Why do you want the one of the remote to light?
Make sure that it is working.
Sometimes if it is big, fails, that's now what? You want to have a remote and say it is working, so you are happy it is working without having where it is working. So the electromechanical switch used in telephone exchange will be, so we can't start talking about the exchange. Telephones now have, I mean, is there anyone, even some, if it wasn't the issue of the battery, no one would be holding cartouche. People hold the cartouche because of the battery, like the Nokia phone. People carry that phone because it is only for calling, so the battery is safe. If now the WhatsApp is on and the Wi-Fi is on, it is only big drain on the battery. Now if I again start receiving calls, and some of you even put in the loud speaker. That's why for me I don't call people. You find that the people are in the conference and they are talking to you, especially the ladies. Hello, sir. And all our friends are there. You say, yes, what is it?
You broke him.
Sir, but you see my marks. What do you want? And all our friends are like, they don't want to be hard. So I don't, and when you have in the loudspeaker, I know, because there is an echo. So when I call you and we are talking and I hear an echo, I ask you, are you on loudspeaker or not?
But now they are.
You have to explain the reason why you are doing that. Doesn't matter whether you are relative or whatever.
But they are improved it.
Yes, there is no feedback.
No, there is no echo.
Yeah, if you are using the cartouche, I will hear. This one, sometimes people are using the handset or using the Bluetooth, so you won't hear the echo because it is in the ear. If you are using even if you are using, well, I know there are some apps which can cut off that bit of the echo, but if you are loud enough, there is not, it doesn't.
Now, for the new Samsung.
I don't want to know about your Samsung phones. Let me finish my course. So the indicator, if you are on a motorcycle or in a vehicle, when you put indicator, it keeps doing that clicking is because of the bimetallic strip. So you have two metals of different expansivity or different properties. And the idea is that once you switch on the indicator, for example, to the right, so you have this is your metallic strip. So the outside one here will expand more. So assuming this is the contact point, so when it touches there, it hits up. When it hits up, it expands. So you are broken up. Immediately it expands, then it cools down. So when it cools down, it comes and makes another, the second contact. So then it heats up, it leaves. So that's why you have, as it keeps making the contact and off. That's how indicators work, by using a bimetallic strip. Then the thermostat depends on where you are using it. The fridges use a thermostat. You will even the vehicle has a thermostat. You put this one here. The moment the whole thing has warmed up and there are no more water drops, then it just, you hear clicking, then it goes off. You can put it on, but even if you put it on, it will last for a short time and go off again. But if it is raining and it is still wet, it will continue warming up takes longer. But if you put it when there is a sun, it will go on, but immediately go off. The fridges, once the inside of the fridge is cool enough for your fruits, then it goes, you hear, then it's like it is off. Then after some time when things are warmed up, then it starts making noise. And then it cools down again once things are cool. So this is automatic switching. So you don't want to waste resources. You don't want to waste power.
Like a percolator.
Yes, like a percolator. If you are using a kettle and you are fake, you put the kettle and then you say, let me take a nap. You wake up when if your kettle has no thermostat. You wake up, if you are using suicide. Do you know suicide? Suicide is using this coil here. A heater. So you have a coil which is like this. This other part which is like this. So it goes like this, goes like this, and probably then the other bit I think comes and goes through. I don't know whether this is the right way of going through. Okay, here is the top, and it comes like this, and then you have the part, and then you have the wires, the socket. This one, you put in no thermostat. You put in a jug, you put water, you put in power, it will heat the water, the jug becomes empty, it heats up the jug. And you hear the smell, a nice smell of plastic. Because there is no thermostat. The more the world is advancing, the more they are making things automated. At ICDP where I was, ICDP is short for International Center for Theoretical Physics. Most of you can go there if you work hard. They have a diploma program. Most of our students have gone there, direct to ICDP in Italy. Others have gone through Rwanda. There is a similar ICDP center. And those who go to Rwanda, when you do their diploma, it's automatic entry to PhD program. So we got students who went to Rwanda and now they are in Texas, in Houston University. So those who are in Houston University are doing their PhDs. It's up to you.
What are the requirements?
Requirements is that you have to excel. They want people who want to chop numbers, not those of you who want to go and do the selfies. They want you to go and chop numbers, and kids there chop numbers. Blackboards are everywhere. The rooms where we were staying, there is even a blackboard. So I never had time, but I took some video when I'm chopping numbers on one of the blackboards. But the point I was making is that they give you a badge, and that badge opens all doors. All. You just go put authenticated, you enter. Wherever you are supposed to go, where you, of course, when you are the center, the main building, to the library, to the whatever, you use the card. Now, every toilet has sensors. So when you enter, the lights are off. When you reach like this, they go off. You don't touch nowhere. When you go to the airport, I'm not sure, I don't know whether I ever entered the toilet at 11, not remember, but I think I did. All of them have sensors, so you don't have to start opening the tap. You just go there and do like this, water comes, then it stops. Then you, if you are not yet ready, then you go to the blower, the one to blow your hands and you cool, you kind of dry up. You put, then you do like this, it blows some hot air on you, not touching anything, because they are using the sensors. So like if I came here, I shouldn't be even touching anything. I enter here, these lights see me, they go on. They said it's a badge. The one of the badge. Oh, the lights.
If it's the door, just open it.
They use drugs and
I've already said that we were using badges, like your ID, like I use an ID on the gate. When I'm coming with the vehicle, like I told you about my problems with my other vehicle, which which has no number plate. So when I reach there, I give, or if I reach, I put the ID. Then the thing opens. So that same ID should be able to open for if we had doors, which makes sense. And the idea is that your information will be registered that you entered in physics at this time. Then this happened, and you were in physics. So, but also they have cameras everywhere. There are cameras everywhere. So, like for you, is there anyone of you who can accuse me of saying things in class? I solved that problem. You can't go around saying BFT saying the vice chancellor is fake. Because I'll be able to come and say here is the raw video. That's how I used to abuse secondary school kids. I used to say, you are lucky. I'm a teacher, a professional teacher. Otherwise, I would have said you are stupid. Yes, I have already said they are stupid, but I have put a disclaimer. So you will be able to read about the bimetallic strip, and then the matrix switch, and then read about the actual automatic switch here. And then you can also go ahead and read about how a remote control works. And you can make your own remote control by the way. Did you know that? This robot here, you can use one of the bricks. When I say bricks, the brick is this big head, the brain. It's called the brick of this robot. You can use one as a Bluetooth, how do you call these things, which you use for playing games? What? Game pads? Yes. Why do you use the word pads? Yeah, pads. Okay. Can't you use some other word? Controllers. Yes, game controllers. I don't want to have problems. So, the game controller, you can use one like a game controller via Bluetooth and be able to run this robot. You can make another vehicle and drive it around using one of them. The other one is because what we made was, I'm sure you are hearing stars, but after Wednesday, next week, you also be understanding what I'm talking about. So this marks the end of the course. After you have understood what the remote control is all about, if you got a transistor, you can get, if you got a transistor, you can make a small remote control whereby you can switch on some LED here by switching on the current to flow within the transistor here when they are not connected. So you can even Google and say, how do I make a simple transmitter using a transistor? You'll be able to see a simple circuit. You have a transistor here, and then you have a switch, and they have some small current for VCC. And once you tap it on, you find that the LED here, which is also powered, goes on. And then you can now do the coding. So the reason why we say this one is now for channel this one is for volume, now that comes to coding. Like how you want to program it, to do what you want. Then there are what we call universal remote controls for TVs. You find this one remote control, but you can put in a code for a particular TV. But the one I had was for basically for traditional TVs like Panasonic, Sony, these other things like Sony and Osima wouldn't be there. And we would have one remote control. After putting the codes, you use it for all of them without hassle. But of recent, I have a funny bit. I have Sol Star, which I use in my office, and it has the same remote control as Hisense. Everything is the same. But one is called Sol Star, the other is called Hisense. So, unless if you have a lot of problems, a lot of questions, we shall meet on Thursday anyway, and then revise the test. And then if you can be kind to me, and by Thursday you have just come through, then you have some concerns related to the course outline, okay? Keep on the course outline. I will. Yeah, I'm saying that because this book is these notes I summarized through, and the books that are on Mwene are too wide. They will talk about all sorts of stuff. But the course outline is telling you what you are supposed to cover. And it is also on Mwene. So I am considering that the course is done with pending test results, and if I find that you have flopped the test, then we can do another test on Thursday. But I'm not worried. I'm sorry. I could have wanted it. These 2 weeks we missed are too much. But I also wanted to have a break from the hustle. I really wanted to be away from hustle, and I can assure you I was away from the hustle. I would just move from the center, walk to the hostel or call it guest house. In the morning I walk to the center, others would wait for a shower or whatever, I would walk and I would talk. I told you, I would walk talking as if I'm with someone. If anyone was keen, they would say that African is mad. I would go talking to myself. No, not that. I would be reasoning too.
Be joking in the head.
Okay. Any other queries? Yes.
On Monday, we are interested for lecture 6.
Up to 13.
For what? We are speaking on the course outline. We are speaking on the course outline.
Is that on the course outline?
Margaret, it is okay. I'm gonna do the.
No,
It's okay. I understand.
We said that last, we don't have the...
No, it's okay. I'm gonna do that. Don't worry. Don't mind that fella. But whatever I was saying is also in the books. But I will be able to put that. If there are no other concerns, I'm always interested in keeping time. So we meet on Monday. The electromagnetism is, as usual, marathon. So we shall do marathon in conduction in electromagnetic waves is it in Marana? Or we shall be doing anyone here who doesn't do electromagnetism one, I don't bother them. Okay, so we meet on Thursday at 2. I just recap on your issues. Please, the things that I have jumped, like my video of inductive capacity, inductive transducer and capacitive transducer, I think they are most viewed. One is 1.something K views. So you can also look at those videos. I don't know, I was very enthusiastic those days when I was teaching the course. Even the way I taught electronics those days was nice. So I hope I'll improve for the next group which is coming. Ma, you are impatient. I got 3 minutes. You remember you came late, eh? You have an appointment. Eh? You can wait. Okay, I see you on Thursday. And then of course for electromagnetism we shall meet on Monday as usual. I hope by next week I would have finished marking all of them. to have one crew.
You take number.
Okay, have a good night.
Use how you